Miss Luxemburger, if you like, or someone else, but I think you were the fastest with the video. Then we come to exercise 4.1 and C. Okay. So again, we want to formulate the Bernoulli's law, and we want to formulate it now for position 1 to position 3. Yeah. And from position 1 to position 3, we get a lower diameter. But because we have an incompressible water, yeah, or second, we have an incompressible media, for example, water. Yeah, we have water. And so if a diameter changes, we have the change of the velocity. And C3. Okay. Okay. And for 1 must be for 3. Okay. So the velocity will also always change with the area. Yeah. Okay. So if we have now, let's say, we have C7. C7 was, I look back, in 12.56 meters per second. Okay. This was C7. So we can recalculate by the areas and the diameters C3. And let's look back to C7. C1 was 6 centimeter. No, it was the wrong exercise. I'm sorry. So, genau. So, D7 was 0.1 meters. So, A7 is okay, look, A7 is P7 square. And maybe can someone calculate it for me? Now I follow the chat. Please try to calculate A7 for me. If someone is fast. And I also want to calculate okay, D3 was, I have to look it up. Wait a second. D3 is 0.2 meters. And meanwhile, you can type to your calculators D3 squared. How big is it? Can you give me the results? Because now it's find my calculator. Okay, who is a fast typer? Who can calculate? Now I start also typing, and I am pretty fast with it. So let's say the first diameter is 7.5 and so on, 10 square meters. And the second is divided by 4. It's about okay. Okay. Now let's calculate the volume flow first. So we calculate. We had the volume flow already. Okay. Can someone tell me the volume flow? How big was it? Bit crazy. I can't see the chat. Hi guys. Can anyone tell me the volume flow from the exercise?
0.09865.
0.09865. Perfect. Thank you, because I already deleted this sheet. Okay. Divided by the area. For 1 square meter. And now you get, I do the calculation. 0.5 divided by the calculation, and it's about 3.14012 meters per second. Okay, so at position 3, the velocity is a bit lower, yeah, and at position 4, 5, 6, 7, it's everywhere the same because we don't have a diameter change. Everywhere it's 12.56 meters per second. Okay, it will not change because the diameter will not change. And now we must calculate the pressure 3. I want to open a new sheet. So 4.1 exercise 3. And now again, I have to make the balance, the Bernoulli's balance, as we already know it. P1 plus square plus the height equals P3 plus O plus 2 plus O, okay, that's 3. Yeah, and because we have no losses, both sides have to be the same. Left hand side, right hand side, the balance has to be fulfilled. And now we can calculate. We have now the different C's, and we can now calculate the P. P3 equals P1 plus rho G times Z1 minus Z3 minus O2 divided by C3 squared. Okay? And we can now calculate the result. C3 is 1.2 10 exponent 5 pascals. That's our pressure here. Yeah. Plus 99.45 kilograms per cubic meters times 981 meters per second. That's our gravity constant. And the sets 10 minus 4 meters. Okay. And minus, this is plus. We need a minus here. 999.45 kilograms per cubic meters times 3140 meters per second squared. Okay, and this is 1.739 times 10 exponent 5 pascals, and this is about 1.739 bars. Okay. Okay. And now, okay, this was from 1 to 3, and now we have to do it from in the same way from 4 to 7, and from 1 to 5, and from 6 to 7. And we will do it because it's an important exercise and you have to practice it. We want to add the Bernoulli equation from point 4 to point 7, and we can do the same balance. No? So again, we have P4 plus 1/2 O C4 plus Z4 equals P7 plus 1/2 C7, and of course squared plus OGZ7. And this will lead us to the equation P4 equals P7 plus Z7 squared minus Z4 squared plus Z7 minus Z4. And I think you agree with me if I don't really calculate it. I just give you the result for this calculation. And for the point from 1 to 5, we do the same balance. P5 plus 1/2 O C5 squared plus O G Z5 equals P. Okay, I can also write it on the other side. Doesn't matter. C1 squared plus O. And we will get equation for this for P5. It will be P1 minus Z5 squared plus Z1 minus Z4 5. And I've already solved it for you. It's like in a cooking studio. I already prepared it. Lex 8, 10 Pascal. Okay. And now if we come to the point from 6 to 7, or for if we now solve the Bernoulli equation from point 6 to point 7, or 4.1 to point 6, this is really easy. Get the same calculated like before, and you get here 1 bar. Okay, is this now okay for you? Did you get it? I think we can now stop the recording, Miss Luxemburger.